So section 6.4, as you can already tell, this video is going to be a little bit different than the previous ones because I'm not going to spend any time on this. There's only one major thing that this whole section is about. It's called linear graphs. And your job is to determine if a graph is a linear graph or not. And it's really, really simple that I'm not even going to make you print off the notes on this. I've got it for your availability if you want to print them off. But don't waste your time. Just look at the thing and see if it's a graph or not. So let's just get on right straight to it. A linear graph is a graph that's a line. Well, that makes sense. However, it cannot be a vertical line. It can be any other type of line, but it can't be vertical. So we have a little graph here, a little table. It says to graph it and tell me whether it's linear or not. So my x values, -2, 0, 2, and 4. And then I have 4, 0, 4, and 16. So I'm going to count by twos on my x-axis, 2, 4, 6, 8. And I'm going to count by fours on my y, so 4, 8, 12, 16, okay? So I'm going to plot those out there, and let's go ahead and do the same thing. -2, -4, -6, -8, -4, -8, -12, -16. Let's plot this stuff. So -2 and 4 would be here, 0, 0 would be here, 2 and 4 would be here, and 4 and 16 would be here. Just by looking at this thing, nope, this is non-linear. Why? Because it didn't make a line. It's not even a straight line. If we were to draw it, it's a curve. Okay, let's look at the next one. I'm going to count by ones on everything, I think. So I have 1, 2, 3, 4, 1, 2, 3, 4, -1, -2, -3, -4, -1, -2, -3, -4. Let's plot this thing. -1 and 1 would be here. 0, 1 would be here. 1 and 3 would be here. And 2 and 5 would actually be right here. And if we were to kind of connect the dots with a straight edge, let's see if I got one. Yes, I do. I connect my dots with a straight edge. What do I have? I have a line. So yes, this is indeed linear. So let's look at number 3. Is this linear? Yes. Why? It's a line. Is 4 linear? No, it's not. It's not a line. It's a little thingy. This is actually what we call an absolute equation, but anyway, it doesn't really matter. Look at number 5. Number 5, table shows area of a square with side lengths x inches. Does the table represent a linear or nonlinear function? All right, so pause. I could graph this thing. I absolutely could. Wouldn't cause me an issue whatsoever, and we could get an answer on that. But I'm going to be lazy. I'm going to show you something. Notice the difference between the x's is a +1, a +1, a +1. And then I have a difference between this, +3, +5, +7. If you notice that the A does not have a constant change. If we were to really make this statement, a line has a slope. We already know that from our studyings of line, and that slope is always constant. It has a constant rate of change. Look at this. I went 1, 1, 1 all along my x's, but my a's, or my y-axis, whatever you want to call it, it had a different change. It wasn't constant. So the answer to this is simply no. It is nonlinear. So it's nonlinear because it has no constant rate of change. And to be more specific, if we graphed it, you would see that. It would not make a straight line. And that's it for this video. At 4 minutes and 22 seconds, I'm closing. Bye-bye.